Hi, seventh graders. Today we are working on page 34. This is going to help us get into our new standard. We're barely going to get into it today, start to investigate what it's all about, and then we will spend time next week and after Thanksgiving break really diving into this. So today is just kind of a discovery, figuring out what is coming next. So get out page 34, pens, pencils, whatever you need to take some good notes. This is the saltwater and sore throats tasks. Task singular, only one, not plural. So here's what it says on the top. You need to know Nia and Trey both had a sore throat. I'm reading this stuff right up here. Nia and Trey both had a sore throat, so their mom told them to gargle with warm salt water. I don't know if you've ever done that. It does not taste good, but it actually does help your throat feel better. And in fact, warm is good, but if you can handle hot, it seems really weird and counterintuitive, but actually sipping a hot drink will make your throat feel better way more than a cold drink will. Okay, anyway, just, the more you know. Nia mixed 3 cups warm water with 1 teaspoon of salt. Okay, keep that in mind. Nia did 3 cups warm water with 1 teaspoon of salt. Trey mixed 1.5 cups warm water with half a teaspoon of salt. We're just going to focus right now on part A. Nia tasted Trey's salt water and then said, I added more salt. So I expected that my salt water would be more salty. It's true, she definitely added more salt. So why do they actually taste the same? Nia was convinced that her water would be saltier than Trey's water, but in fact they taste the same. Your job is to provide Nia with an explanation for why the 2 salt mixtures taste the same. Why do they taste the same? Use some kind of mathematical reasoning to support your answer. This can include visual representations, tables, numerical calculations. That means numbers, math, something, anything. This space here is for you to explain why those 2 mixtures actually taste the same. And you guessed it, right now you are going to pause me and take a minute and do whatever makes sense to you. Pause the video and try part A. Okay, did you do it? I sure hope you paused it and tried something. If you haven't tried anything, if your paper is still blank, pause me and try something. Don't be afraid of getting things wrong. Now, I'm going to show you some things. I actually had the members of my family try this for me. And I just said, do whatever makes sense to you, exactly like I said to you. And I'm going to share with you some of the results right now. Starting with Penelope. Penelope is my 5th grade daughter. Now she has a little bit of a disadvantage then in working on this because there's a lot of knowledge from 6th grade that would really help you answer this question, and she doesn't have any of that knowledge yet. But I wanted to show you a really important thing that Penelope said. So this is Penelope's work. It says, Nia's water tastes the same because she added more salt, but she also added more water. Yeah, and that's kind of a basic thing. So she showed in her picture here, she gave me a nice little drawing, which I really liked. She said, okay, Nia had 3 cups and 1 teaspoon, and Trey had 1.5 cups of water and half a teaspoon. So she's saying, sure, she used more salt, but she also used more water. So there's got to be some kind of balance there, right? And mathematically, we do have words for this and balances that happen. And then she was trying, and this is when she brought me her paper, and she said, Mom, I tried everything I knew how to do, and I was trying to see if I could get these the same or figure something out here, but it wasn't getting me anywhere. And I love that she was trying things and tackled stuff, even when she doesn't have the 6th grade knowledge that she needs. But that is an important point. And she actually tried to multiply those values, which was a really good idea, but not actually quite right, and we're going to look at why. So, okay, so obviously it's something to do with a connection. We have to not just look at salt, Nia. We have to focus on the salt compared to the water. And we're going to remember some important math language with that in just a second. I also had Mr. McGowan, Penelope's dad, my husband, try this out. And he said, well, they're the same because Nia's mixture overall is just twice of Trey's mixture. Okay, so he said her 3 cups and 1 teaspoon is double, and he set this up in a way that shows like if you distribute this through here, he's just saying this is just half of this, or this is double that. So again, Mr. McGowan was also saying you can't just compare salt, you got to look at the entire mixture, water to salt. Okay, my older daughter, Adeline, set it up like this. She started looking at, again, a comparison of salt to water. And when she brought this to me, she brought up a really important math language word, and that word is ratio. Okay, when we're comparing this and we're trying to say whose is saltier and why, we simply can't just say, we can't just look at the salt and compare the salt. We have to put together this idea of what's happening with the water compared to the salt, and we do so in a ratio. And she put this also in language of what's happening salt per cup. And so this is a ratio of water to salt. And the question is, where did she come up with that ratio? And that's what I want to make sure you guys have. Where Adeline came up with that ratio of 1 to 3. Penelope was actually on the right track, but she was multiplying. And a ratio, if you recall your definitions from 6th grade, and we'll write it down. A ratio is a comparison of numbers. I'm going to write it over here. A ratio is a comparison. It's a comparison of 2 values, but it's a comparison by division. Okay, so this is about division. Whoa, didn't mean to circle through that. But so since we are doing a comparison by division, if we look at cups to water to salt, that ratio was actually coming from doing a division problem. And Adeline did her division. If she got 1 to 3, she was thinking 1 cup of water. She actually didn't get 1 to 3. She got 1 to 1/3, which actually means she was doing salt to water. Let's see if we can get a ratio of water to salt to make sure our division is going in the correct order. So we're going to do 3 cups of water, this is the water, over divided by 1 teaspoon of salt. Okay, so if you don't have these ratios written down anywhere, make sure you write them down. So it's 3 cups of water to 1 teaspoon of salt, and then 1½ cups of water to ½ a teaspoon salt. Okay, now if you actually do this division, 3 divided by 1 is a 3 to 1 ratio, and 1½ divided by 1/2, or if I change those to decimals, it can be a little bit easier to divide. 1.5 divided by 0.5, look at that. This is also 3 to 1. So yes, she used more salt, but she also used more water, and it turns out in terms of a comparison between them, they have the same ratio. So we're going to put, they both used a 3 cups to 1 teaspoon ratio. And this is also a reminder here that we write ratios. In 6th grade, you learned that you can write a ratio like this, 3 to 1, or you can write it like this, 3 to 1, or, and this year, we're going to write it in a more official math way as a fraction, 3 to 1. All of those are showing the same ratio, but that's the key word here that needs to be brought back, is that we are dealing with ratios, and a ratio is a comparison of numbers by division. Okay, let's read and try these other parts together now that you've tried that first part. And you've seen how my whole family tried it. Right here it says part B, come up with 2 more salt mixtures that would taste the same as Nia and Trey's mixture. Well, in order to taste the same, you need to make sure that you have a ratio that will still come out as 3 to 1. So let's say, for example, I wanted to mix 6 cups of water. If I use 6 cups of water and I need it to be the same saltiness, then how much salt would I need? Well, if I need this to turn into 3:1, then I need this to be 6/2 teaspoons of salt. Why? Because 6/2 would turn into a ratio of 3:1. Okay, and I could pick anything. We could get a little more creative. I don't know, let's do, what if I used 4.5 cups of water? If I used 4.5 cups of water, guess what? I could use 1.5 teaspoons of salt, because that is still 4.5 divided by 1.5 is still a 3:1 ratio. Those certainly are not the only examples, but those are 2 more mixtures that would give me the same saltiness as Nia and Trey's. Okay, well, what about part C? What if I want 2 more salt mixtures that would taste saltier than Nia and Trey's? If I want them to be saltier, do I still want a 3:1 ratio? Remember, 3 is the water, 3 cups water, and 1 is the teaspoon salt. Do I still want a 3:1 ratio? If I want it saltier, which one of those values do I need to go up? The salt, right? So I could actually totally leave 3 cups, I could leave it as 3 cups of water, and just instead of 1 teaspoon, I could use 2 teaspoons of salt. 3:2 would end up saltier because the water stayed the same, but I'm using more salt. And really, I could keep 3 cups of water and change this to whatever. But I could also change, like, let's say I did 12 cups of water. Think about, first of all, how much salt would make it the same. 12 over what would make 3? 12/4 would make 3. So if I want it a little bit saltier, I might do 12/5. Because watch, 12 divided by 5, oh no, 12 divided by 5 is only 2.4. Well, that's what we want, is we want less water than salt. So some people think that it's supposed to be higher than 3, but it's actually 2.4 to 1, which makes it saltier because there's less water. Okay, so 5 teaspoons of salt. So there's 2 mixtures that would make it saltier, but it's all about a comparison. Like Penelope said on the first paper, she changed the salt, but she also changed the water. These 2 are working together as a ratio of water to salt. Okay, last section here, part D. Consider 2 more salt mixtures. Mixture A has 3/4 cup water with 1/4 teaspoon salt, and mixture B has 5 cups water with 1.5 teaspoons salt. These 2 mixtures do not have the same saltiness. They will not taste the same. Which mixture is saltier? Well, the way that we're going to tell that is we are going to check a ratio. Let's start with mixture A. Let's do a ratio of 3/4 cup of water divided by 1/4 teaspoon of salt. In this particular standard, you're going to see lots of what they call complex fractions. It's a fraction within a fraction. Now you can leave them fractions or you can change them to decimals, but if we deal with this as this means the same thing as 3/4 divided by 1/4, which if you recall all the way back from our earlier NS standards is really 3/4 times 4/1. And of course you have calculators to help you with any of this, but now we can simplify, and that's just 3/1, which is a 3:1 ratio. So this one has a 3:1 ratio. That one actually has the same saltiness as Nia and Trey's. Okay, let's look at mixture B. Mixture B is 5 cups of water with 1.5 teaspoons salt. And you know what? I'm going to treat, this is really 5 divided by 1.5. I'm going to change the 1.5 to a decimal so that I can type that in a little bit easier. 5 divided by 1.5 is 3.3 repeating. So this is a 3.3 to 1 ratio. Remember, this is cups of water and this is teaspoons of salt. So this is water to salt and this is water to salt. So the question is, which one is saltier? This is hard to tell because the salt is the same. But if this one has 3 cups of water with 1 teaspoon salt, and this one has a little bit more water, but the same amount of salt, if you add more water, does that make it saltier or less salty? Adeline, if you add more water, does it make it more salty or less salty? More water, will that make it more salty or less salty? Less salty, correct. So actually, mixture A, which mixture is saltier? A is saltier because they have the same amount of salt, but A has a little less water. Okay, ratios and all things. We're going to review things ratios from 6th grade, and we're going to learn a lot of new stuff with this year. We are now headed into a brand new strand. We finished the EE strand and are ready to start a new one. Congrats, guys.